The next part which we are going to see is cleansing, integration and transformation in data science process. So uh, in the phase of data preparation, we have three categories. First one is data cleansing, second one is data transformation, and third one is combining data. So data cleansing can be applied to remove errors present in the data. So if there are any values which does not fit within the range, so for that data we can apply data cleansing. So if in case some values are missing, then data cleansing can be done. So if some values lie outside the range, then data cleansing can be done. So if there are any unwanted spaces or typo errors, so then you can apply data cleansing. And if there are any error against the code book, then also you can do data cleansing. So we'll be seeing about all of these things in detail. So as I've told you, data cleansing is a process that focuses on removing the error that is present in the data. So this is actually done in order to make the data a consistent one, and in order to make any analysis with that data, the data should form a true and a consistent form. So in order to do that, cleansing has to be done. So now we'll see about outliers. So this graph is actually plot between distance and row number. If we clearly see, most of the data lies in the range below this red line. So the range of these values are actually, it is in the range of 0 to 100 in X and 0 to maybe 0.5 in Y. So, but here at a distance, you can see a value, okay, which is encircled, and it does not fall within the range or does not fall in this region. So such a value is what we call them as an outlier. So any value which is not actually present in the actual data range, and if it is present outside the data range, then that value is what we call it as outlier. So there can be two cases. One, so these outliers data might actually be an error in the data prediction. So, or the second category can be by means of some analysis, we find out that the data which is identified as outlier is actually the correct data. So, the case can be either one of the two. So, next, we'll see about data entry errors. So, data entry errors. Actually, data collection and data entry is actually an error-prone process. Why it is an error-prone process? Because it is actually requiring the effect of human intervention. So, whenever human makes any data entry, they are prone to have more typo errors, or sometimes due to the loss of concentration, there can be an error introduced into the data. But this doesn't mean that the data collected by machines is free from error. Okay, so there can also be some errors, but not as high as in the case of human entry process. So sometimes errors can arise due to human sloppiness, and in case of machines, errors arise due to machine or hardware failures. So we can see an table here. So the number of times good is typed as good, it is somewhere around this value, and bad is typed as bad, it is somewhere around this value. And sometimes in a data entry process, sometimes due to the typos, it can either be typed as GODO. So see the count, it is actually 15 times the word good has been misspelled as GODO. Similarly, In case of a bad, some extra letters being present or added at the end. So these are considered as the data entry errors. So these errors has to be removed. That is what is done in a data cleansing process. So redundant white spaces. So white spaces are actually hard to detect. Okay, so why? Because it might result in errors like other redundant characters would actually make an error. Okay. So capital letter mismatches are common. For example, in most of the programming language, there can be a distinction made between the word Brazil and this Brazil. So if we clearly see the difference between these two words are only the first letter is caps in this one and this is small in the other word. So in case if the machine has to identify the difference between these two words by using any programming language, so both a function has to be introduced to find out if the letters are present in uppercase or lowercase, and both has to be set as true. So in that case, the machine can effectively effectively find out that both the braces are the same. Even if any of the letter is capitalized, that will not be misspelled or it is not identified as error. So we can also have sanity checks. Sanity checks is a type of data check. So in the sanity check, we can set a rule like this. For example, if we set a rule like 0 less than equal to age less than equal to 120, something like this, which means the age has to lie within this range between 0 and 120. So sometimes if you are entering a value above 120, then it has to throw an error directly when entering itself. So this is called a sanity check. This is made in order to avoid errors during the data entry process. So next we'll be seeing in detail about outliers. So as I've told you, outlier, it is actually any observation or value that actually does not fit in the range of the other observations closer to them, and it lies far away from them. More specifically, sometimes there might be some observation which follows a different logic than the other observation. So as a result, what happens? That observation will lie in a different range when compared to that of a normal observation value. So how can we find the outliers? We can actually find the outliers if we can visually represent the data. So if we represent the data using any plot or table, then we can actually identify the presence of outliers. So first example is shown here. So actually this is the expected distribution of the data. So it follows some pattern like this. So if we are able to plot the data in form of a plot like this, so we can easily find out. See, because actually the data has to fit within this range, but due to the presence of outliers, the data is now present in some other portion. So this helps to easily detect the outliers and also to easily understand the variation of the data with respect to the expected outcome. So how to handle the missing data? So there are techniques available to handle these missing data. So first one is to omit the values. So omitting the values is very easy to perform, but the disadvantage will be information will be lost from the observation. Second technique is setting the value to null. So this is also very easy to perform. so implementation has to deal with some null values. Maybe if we are putting or sending these data to any ML or DL based technique, so it finds difficult to deal with these null values. So that can be the disadvantage. So the third technique can be we can impute a static value such as 0. So which means wherever there is any error present, we can actually override the values with zeros. That can be done. Or the mean. So the mean means all the other values present in those columns can be utilized to find a value closer to the missing value. So that value can be filled in the error place. So this is also easy to perform. So by means of doing this, we will not lose any information. That is a important advantage of this category. But however, it might lead to some false estimations if we use any ML or DL based techniques. So fourth technique is imputing a value from a estimated or theoretical distribution. So previously we have seen a distribution graph, right? So likewise we can make or plot the data in form of any distribution, and from that we can take a value and fill in the missing value. So advantages, it does not distribute or disturb any model which we are using, but however it is very harder to execute. In the sense, if we have very less data, visually representing them will make the process very clearer. But however, if we deal with the huge volumes of data, then it becomes very harder to execute and very harder to find. So the other disadvantages, we are making assumptions. So last technique will be modeling the value. So this is, I mean, this also does not disturb the model too much, but however, it has few disadvantages. So it can lead to too much confidence in the model. So it can artificially develop some dependencies between the variables, and sometimes it becomes harder to execute, and we are making some assumptions. Although it is considered best among all of these five, it also has its own disadvantage. So deviations from a code book. So code book is actually description of the data. So it actually contains the data such as number of variables, number of observations, what is the encoding technique used within the variable. So for example, sometimes we might have a table kind of a thing where we equalize 0 to negative and 5 to positive. So all these interpretations are actually available in the code book. So it describes the data present in the codebook. So next category which we are going to see is combining data from different data sources. So combining means technically speaking, it is joining the data, which means we have two different tables based on a particular column which is set as key. One table is actually joined with the other table. So that is what we call it as joining. So the second process is appending or stacking. So appending or stacking means from one table we take some observations and we add it to the other table. So that is what we call it as appending or stacking. So joining. So joining actually it focuses on enriching a single observation. So if we want to join tables, we need to use variables that are common in both the tables. So we call those common fields as keys. So if those keys which are used for joining the two different tables, if they are uniquely present in the table, then we call them as primary keys. So we can see an example here. This is one table and this is the other table. So we have client here, John Doe and Jackie. So this client is common in both the tables. So uh, using this client, so what happens? We can merge both of these tables. So as a result, we get a single table with all the fields from both the tables. So this is joining the tables based on key values. So appending. Suppose if we want to merge both the tables into a single table, then we go for appending. So here we can see an example. So this is table 1 and this is table 2. So both has same fields like client, item and month. So one below the other, both the data from both the tables are appended together or merged together. So this is what we call it as an appending. Next comes the views. As in the case of appending or merging or joining, which we have seen earlier, these views actually do not combine the tables. They virtually combine, and this is more specifically used for viewing the data. Suppose we have a thought like if we merge these two fields and I mean tables, and if we want a particular table to look like this, then we, even before merging them or appending them, what we can actually do is we can go for viewing them. If the view looks great and if it is correct, then as a next step we can go for merging the tables. So as specified, if we want to for example, if we in any stores or any shop, if we want to check the sales based on different months, we can combine together and have a view like this. So this is actually virtual table. So this virtual table just for the purpose of viewing, and it is not actually merged, it is just for the purpose of view. So same example is given here. Enriching aggregated measures. So data enrichment can be done by adding calculated information to the table. So suppose in case if we have only marks in a particular table, for example, marks of a particular student or 5 students for in 5 different subjects. So if that is only present, from that data we can find out total, or we can actually find out what grade he has got, and actually we can decide whether he has passed or failed. So all these things are from the available data, they are derived, they are not actually present, they are derived in order to make in order to make or simplify the process, or arrive at a conclusion from the data available. So that is what you call it as enriching the aggregated measures. So next comes the transforming model. Transforming the data. So if we want to work with certain models, they require the data to be present in a particular shape. So if we want to transform the data to take a suitable form, then we call it as transforming of data. So we can see two graphs here. So in the graph number 1, we can actually see it is taking some arc form. So we have to move this value down, this value down, this value down, and similarly these values up, in order to make these values fit in the linear line. So if we are doing that process, we have to make or transforming the data. So that is what is all about. That is what it is all about. So reducing the number of variables. So if we have too many variables in the table, it creates it creates problem to the model that is used for analyzing the data, because the model has have to handle them, and handling them becomes very difficult. So also we have to keep in mind that certain models does not work properly when we overload them with too many input variables. So the main purpose data scientists always try to do is they use always special methods to reduce the number of variables, but they try to retain maximum amount of data that can be obtained from the variables. So next comes the turning variables into dummies. So dummy variables are something which can take only either of the two values, which is 1 or 0. So presence or absence category will be denoted by this 1 or 0. So we can see a table here. Here gender is there. FM female, male, female, male, female, male, like that it is present. So we can have two different columns called male and female. If the values are female, then female will be 1. If the values are male, then male will be 1. Like that you can have dummy values to represent true and false values in a table. So next comes the data exploration. So exploring the data rather than having the data as numerical values, if we can project the data in form of some graphs, then we can easily analyze the data or make many modification to the data, or it will make our process of finding out the suitable model an easy one. So data exploration can be performed using simple graphs, combined graphs, links and brushes, and even non-graphical techniques are available to explore the data. So as I've told you, rather than seeing the data as values, information becomes much easier to grasp if we can project them as pictures or using graphs. So it helps us to have easy interaction between the variables. So the various visualization techniques available are simple graphs, histogram, Sankey, and network graphs. So here we can see a bar chart. So this bar chart is constructed for some particular data. Rather than seeing the data like that, if we could project it as a graph like this, it helps us to easily analyze which range the data is present. Which year it has performed, like so that all analysis can be easily performed using this bar chart visualization. So next is another example line chart. So it shows the trend, how the data has moved over years. So distribution, using some probability distribution models to find out where exactly the values are actually distributed in the range. So this helps us to select which model will actually be suitable for which type of data. So that convenience will be provided by this way of data exploration. Next comes the overlaying. Overlaying means putting multiple number of plots together on a single screen so that we can easily compare them and understand the structure of the data over multiple variables. So that can be done. So this is called overlaying. In a single graph itself, we project or subdivide them and put so many number of graphs in order to make the data visualization process an easy one. So this is called as overlaying. So last one is brushing and linking. So this brushing and linking actually allows to select observation from one of the plots and highlight these observation in the other plots. So for that process we use the brushing and linking. Thank you.